So I want to share this disclaimer before I start this part of the course. With this approach I'm about to showcase of importing separate advanced skeleton rigs into the main rig file, a lot of the picker features that advanced skeleton needs to run operations on the rig will not work on the imported parts of the rig. I will resolve this issue at the end of the course when I have all these separate rigs imported and set up. It will require some addendums to the picker mail file that will be shipped with this rig, or an extraction and editing of the code needed to run some of the more important functions like IK-FK matching from the shelf. All right, let's proceed with the lesson. So before we move on to the tail, I'm going to do some quick cleaning up. That low resolution mesh I brought in here to do all the skinning and to do the cut up stuff, it's now time to delete it. It's skinned to the main skeleton. We don't need it. So I'm going to unhide its layer and just delete it from the scene, select it and delete it. And I can also lose this layer. So I'll go delete layer. And we're back to our clean scene. Okay, so before we proceed with the rigging of the tail, let me show you the issues I ran into when I tried to do a tail in the way that's expected with the tail connected to the rig. So if I was to import a biped bendy template, well, just a regular biped template, not a biped bendy, it doesn't really matter for this example. I'm going to reduce the joint size. And let's say I was to add a tail the way Advanced Skeleton recommends with this extra limb. So if I get a tail and I go import, so it adds this tail over here. And the tail has specific labels to make it behave. But bottom line is connected to the fit skeleton. All right, so if I now go and I build this, so I go build Advanced Skeleton. Okay, the build is complete. I have a functional tail and it comes with IK-FK switching, which is great, right? So I can switch to IK. But as I said, since the requirement for this rig is that the tail is scalable, if I try to scale it, the only logical way I could think about doing it is through whatever global node this tail has, which it doesn't, right? It would pretty much be this control. Let me add some poly boxes to this so that we could see. Go create. Yeah, so as is, if I was to take the FK controller and I try to scale, well, that's not the FK controller of the tail. Let me find that. There it is. Right. It makes sense that it would be a very difficult thing to do. I can't scale it through here. So ultimately, there's no easy way to scale the tail with the default way in which you are expected to create a tail with your rig. So the first thing I did was switch to rigging the tail in a different scene and bringing it in. So I ended up with a system where the tail comes in and I use the global control that Advanced Skeleton gives you. So Advanced Skeleton gives you a global control when you rig something separately, and that has a group on top of it. So I tried to use that to attach it to my rig in the various ways in which it's supposed to be attached. So there's two locators here. One locator is parented under the root, the other is parented to the global control, and constraints are applied from the locator to the tail's global control in ways that allow the tail to follow along with the body. But the most important thing it was supposed to do was, one, allow me to scale the tail. So if I grab this global control, I am able to scale the tail. But if I grab my actual root control, which has a scale constraint relationship with the group that's holding this scalable global control, I cannot scale correctly. And what's happening here is that usually when you have something like this that uses a spline curve, that curve has to have some settings toggled on and off for it, and that curve has to go through this normalization process that allows it to respect the global control. one of the things you would do with that curve is turn off inherit transforms. Like if it's somewhere in here, there's a curve in here, that curve right there. So if that curve was selectable, I'd go in there and I'd have to turn off inherit transform. Then I'd have to go into the node editor and find this, whatever is being used to, here's an example of a normalization process happening in some way, but it's really messy. It's a lot of nodes and it's hard to go in here and figure out what is connecting to what and what you should consider. And I wouldn't want to do that anyway, because I'm playing with the internal structure of advanced skeleton. I don't really want to do that if there's an easier way. But that is how you would have resolved this and gotten this tail to stop behaving like this. It's all that you see happening right now as I try to scale up and down is being caused by the spline IK curve not knowing what to do as this global control is going up and down. So after a whole bunch of experimentation, I finally got a working model, and that is what we're going to do. So this is the tail scaling with the rig, and also me being able to scale the tail individually by itself, right? And have it not impact. And all this is done with just an attribute that advanced skeleton gives you with the fit skeleton. All right, so let's get started with the tail rigging. This is the file that I isolated the tail into at the beginning of this course. So let's get started by adding a joint. I'm going to write joint semicolon to add a joint to my scene. Considering where my tail is, I am going to move the joint up slightly so it's just at the base of the tail. If I go into the front view, I could probably get a better position, maybe here or anywhere. Anywhere in this region is fine. Okay, I'm gonna go shading, X-ray joints so I can see my joints. And I'm gonna duplicate this joint, move it up to the tip of the tail. Okay. And I'm going to name the first one joint tail A, no underscores, because advanced skeleton will scream at you, and joint tail end. That's the end. Then I'm going to grab these two joints. Actually, I'm going to grab the child joint and parent it to the parent. Now I'll select both of them, go into advanced skeleton, and use my resample to create a total of 15 intermediary joints. This is about a good number that I feel like works. So I'll go resample. Okay, so now I have 15 joints to work with. So the next step from here is very important. What I'm going to do is I'm going to load in one of Advanced Skeleton's templates, more specifically the biped MA. That is going to work just fine, but any one of these templates that has the base fit skeleton node will work. So I'm going to import it, and I don't need a majority of it. All I need is this fit skeleton node and this root. So I'm going to come down here and delete everything else underneath it because we don't need it. So now I have a fit skeleton over here node, and I have my root joint. Now the very important thing I'm going to need from this root joint is this number of main extras. This tells you how many global controls you're going to have for your fit skeleton. So what I'm going to do first is position this joint, this root joint. So I'm going to turn on my joint orient and zero out the joint orient channels because I don't need this root joint having any angles. All right, then the next thing I'm going to do is I'm going to zero out its translate values so that it's at world. And then just to differentiate it from my joint chain, I'm going to increase its radius. Doesn't matter if it's this big, I don't mind. Let me just make it slightly smaller, about that size. And what I want to do now is I want to parent my newly created joint chain to it. So I'll parent it. So now whatever I create will have all the benefits of having this fit skeleton, all these parameters that you can add to the fit skeleton, all this stuff here. All right, then the next thing I'm going to do is I'm going to make sure to change the number of main extra controllers to 1 because I want an additional extra controller. And now before I build, I'm going to set the fat parameter so that when my controls come in, they are the correct size. So I'm going to turn on geometry and I'm going to hit the 4 key. Actually, I don't have to do that. I could stay in this mode. I'll just select my skeleton and start adjusting my fat parameters so they encapsulate my geometry properly. Because as I've mentioned before, with advanced skeleton, this thing determines what your control size is going to be. So my next step is to add IK labels so that this tail has IK controls and FK controls.